Are you getting pressure from finance to justify or reduce your cloud bill? CloudZero is the only cloud cost platform loved by engineers and trusted by finance. CloudZero can identify unused, idle, or over-provisioned resources, alert you to spend anomalies, and organize 100% of your spend into a framework that mirrors your business structure, like cost per customer, product feature, or team. It's the most powerful platform ever built to provide accurate, granular visibility into your total cloud spend without the typical pitfalls of legacy cloud cost management tools like endless tagging or clunky Kubernetes support. Manage cost, optimize development, and maximize profit, all in one platform. Join companies like Rapid7, Drift, and SeatGeek by visiting cloudzero.com/cloudcast to get started. That's cloudzero.com/cloudcast. Visit today to experience immediate and ongoing savings on your cloud bill.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And it is Aaron for a quick introduction. First of all, as I record this, it is actually Sunday evening. I'm heading out to KubeCon in the morning. So even though this won't pop into your feed until Wednesday, it is Sunday for me. And why is that important? Well, just a little bit of a programming note. As we record a lot of these, they're not always recorded and released in order. And as you've heard recently, I just finished a marathon, ran it a week ago now. And we've already talked about it on the show, but we actually talk about the run-up to the marathon in this one because this show actually recorded a couple weeks ago. So that's programming note number one. We apologize. The race has already happened, so sorry for that, but it's quick. And number two, I actually mispronounce Ellie's name, and it's embarrassing because we already know Ellie from the industry, and as we mentioned in the show. So, please excuse my mispronunciation on that, and certainly our apologies go out to him for that. But we have the interview coming up right after the break, and fantastic podcast all about developer testing and how to reduce developer friction. And we're going to get to that right now.
Today's episode of the Cloudcast is sponsored by Datadog. Bring speed and scale to your security organization. Datadog Cloud Security Platform delivers real-time threat detection and continuous configuration audits across applications, hosts, containers, and cloud infrastructure. Built on top of the observability platform, Datadog brings unprecedented integration between security and DevOps aligned to shared organizational goals. As a listener to the Cloudcast, you can sign up for a free 2-week trial to see for yourself how Datadog can elevate your cloud infrastructure security posture by visiting datadog.com/security-cloudcast. Sign up now and receive a free Datadog t-shirt. That's datadog.com/security-cloudcast. And we're back. And Aaron, we are coming up on you being very close to doing, cruel things to your body. How's the training going for the marathon?
Yeah, we are a couple weeks out. The long runs have all been done. All the work is in the bag, if you will. I just have tapered down from here, and so far so good. We'll see how the race goes. But yeah, for those that don't know, I've signed up for the Marine Corps Marathon in Washington, D.C. When we record this, we're about 2 weeks out from the running of it. So it will be an interesting attempt.
Good. Well, listen, one of the things that whenever we get a chance to talk about developers, we oftentimes, we'll lean on friends like our friends from the folks at Monk Chips and those folks. And the thing that they always sort of come back to us with is they're like, look, for all of the interesting things that developers work on, for whatever language they work on and so forth, it always comes back to you will ultimately be very successful or less successful based on how well you do CI/CD and testing, right? Because for all the great applications and great ideas you have, if you can't test it and make sure it works, and you can't deploy it in a at least somewhat continuous basis, you're really just doing and looking like a development environment from 10 years ago where you deployed once and waited a year and so on and so forth. So today we're going to dive a lot into not only CI and CD, but really kind of this evolution of both CI and CD as well as testing, and sort of really look at, what's changing, what's potentially changing in the developer world. So why don't you introduce our guest? Because I think we're gonna really dive into it and really enjoy where some of the stuff's going.
Yeah, absolutely. And so it's really interesting because, again, what a small community this can be at times. Here we are, we scheduled everything, and then we jump on to record, and we're like, wait a second, we know you. So Eli is co-founder at AtomicJar. And so first of all, Eli, welcome to the show. But please give everyone a little bit of background and what brought you and Sergey to create AtomicJar.
All right, I'm Eli.
Sorry, Eli.
No worries.
Sorry, my bad.
All right, I've been in this. So I started my journey in this technology space in a small team inside of Amazon called that ended up being Amazon Web Services. And what I realized when working at AWS in the very, very early beginnings is how different our work cycle was, how different we were building software than the rest of the world was. And throughout my career since that time, I've always gravitated towards environments and towards working on things that can help developers be a lot more productive. And the subject that Brian brought up, the idea of CI/CD in faster feedback, has always been core to what I got excited about. So when one of the developers in the previous company I used to work at told me about Testcontainers and the fact that they were going to build a company around this and build a managed service for it, I jumped on board because it was the most exciting thing I could think of doing. And I have never looked back. It's super exciting. It's super exciting to be talking to developers about how to get faster feedback on the things that they're working on, how to shrink down this amount of time that it takes them to get feedback from, hours, minutes to literally seconds, and how to bring back that feeling that they've had, or at least I had when I started my development journey, where I could just, develop something quickly on my machine, run it quickly, find the bugs, figure out what was going wrong, and do it over and over and over again. What we're seeing in many enterprises and larger companies is that developers they're writing software, but it might take them, a cup of coffee or an hour to get any type of realistic feedback. And that just feels wrong for developers. So we're excited to be bringing a technology to developers that enables the control and enables them to be able to go and really enjoy this process of software development as they used to do when they were first starting out.
Yeah. So we've talked a bunch of times on the show about these sort of shifting left concepts, the idea of moving more of the, kind of getting to the end result, further left. A lot of that's been kind of security centric. We've also talked at various lengths and sort of in different contexts about the idea of, well, if you build it, you run it, and hence you're kind of very conscious about the idea of, building things that have been tested that you feel confident putting into production. I feel like you're sort of talking about some of that, but also a little different context. Help me with sort of the paradigm of where, the concepts of like test containers and this idea of sort of shifting testing left. Help, paint me a picture of what that looks like from your perspective.
Cool. So we've all seen the benefits that the containerization ecosystem brings to packaging software. We've seen how people are able to package, to deploy, and so on and so forth. But one area where I feel less people have spent time is this process of getting feedback on the software that they're building, oftentimes even before they commit their changes. In today's world, many developers get feedback after they've committed their changes and after the software that they are writing has been deployed to some kind of an environment, oftentimes a staging environment. Testcontainers, a library that started first in the Java ecosystem, but is now available in 8 different languages, takes this slightly differently. It says, what, as opposed to waiting until you check in your code and deploy it to some kind of a staging environment, why don't we allow the developer to bring in all of the dependencies that they're depending on, the databases, the message brokers, the cloud emulators, right into their IDE, enable them to create self-contained tests that spin up all of the dependencies that they might want, run their code against it, and when they're done, remove all of those things from their machine. So what this allows developers to do is, as they are writing code, they're able to get realistic, self-contained, idempotent, repeatable feedback for the code that they're writing. And they're able to repeat that process many, many, many times over, even before their code leaves their machine, which enables them to get much faster feedback. I'll tell you a story that I have experienced early on in my software development when I was at AWS, actually. At AWS on the S3 team, this is launch of S3. Lots of we were building software, and we're also having to that software and to be able to patch it if needed. So one of the things we've done is we went and we said, integration tests are super, super important for us. And what we did is we put monitors all over our development area, and there's a status of our integration tests. And in order to shock us, and in order for us to pay attention to this, we had a bunny on those monitors, and the bunny would be a happy-go-lucky bunny that was excited and happy and so on and so forth. That if 80% of our integration tests were passing, but the bunny would be very upset if less than 80% of our integration tests were passing. And the idea was to go and shock us into having to go and take an action in order to make the bunny happy again if tests are not passing. And over time, what we've discovered as we built more and more things, the bunny became more depressed over time because our integration tests were starting to fail because of environmental issues, because of data things, and so on and so forth. And that to believe that, hey, this approach of deploying software to get feedback and waiting until you see, you accumulate all of the changes to get feedback is actually breaking. And being able to get that feedback early in the development cycle is super, super important. This is why the particular approach of test containers and getting feedback early in the development cycle speaks to me so much.
So that's super fascinating, because I always love a great adoption story. And one of the biggest things we see with developers is if you want to change a practice, right? It's a little bit of part culture, part technology. And so other than the bunny, what is a hook that kind of gets folks interested in investing both the time and the resources into better testing practices in general? What typically happens practically?
So I think the interesting part about this technology of test containers is that in a lot of ways it requires no permission by anybody to adopt. What we're seeing in reality is that developers discover it. And it's open source, obviously, right? So developers discover test containers, and they bring it as a dependency to one of their projects. And what they're able to do is they're starting to see, wow, I can get realistic feedback into the software that I'm developing much earlier in my development lifecycle. And that's something that hooks them up. It's something that, it's getting realistic feedback is something that's super exciting. What happens is a single developer could check in their tests into the repository, and now everybody on the project starts observing what happens. And now they're able to go and, get that same feeling. So the way we see this thing evolve is that it's usually adopted by a single engineer who has listened to us speak at a conference or has read an article or two and tries it out and gets hooked, they check into the repository, and then others in their organization start adopting it.
Yeah. So walk us through. This feels like one of those situations that Aaron and I always dread, where one demo would be better than 1,000 words. But where walk us through a little bit of what that experience is with test containers versus maybe what people were used to before. Whether it was like writing tests in some other sort of system and then hoping they could go together, or waiting for QA. Kind of just walk us through sort of the before and after, and maybe sort of the aha moment.
Awesome. All right. Typically, when we go and talk to people, the first thing we do is show, don't tell. So
Sure.
this idea of a demo is very core to what we do over here, but I'll try to describe it. Right. So the problem space we're dealing with is getting feedback on the software that you write. And there is approaches that have been around for a long time. People during development time, they do mocking. They do mocks of services that they depend on, right? And it's fast to get that feedback because they're able to run the unit tests really quickly, but the feedback is wrong. People could be doing integration tests and deploying those tests into some staging environments. And I've just described the challenges of those staging environments, where they could be going stale over time, where they could be having data issue, deployment issues, and so on and so forth. That in essence, the further you go, the less reliable your tests that rely on staging environments become. And then, like, some people obviously test in production, you only live once, and all of that stuff. So, like, in the spectrum of how you can get feedback, Test Containers takes an interesting approach. What it does is it says, hey, a developer should stay in the code base where they currently are. And as opposed to writing mocks, and as opposed to doing unit tests that are false, that are that depend on that actually don't rely on the underlying technology, what we're going to do is we're going to give you a developer library where literally in 2 lines of code, the developer can say, hey, give me a real instance of Kafka, give me a real instance of an Oracle database, Postgres, or what have you. All of things that I would need in order to stand up my service in a real environment. This literally lives in your code and is a couple of lines of code. And then you're able to execute your code as if though it was running it was running and deployed somewhere else. It allows you to, and the library, what the library does is it brings up those dependencies, so the developer doesn't need to know how to start Kafka. The developer doesn't need to know how to start an Oracle database. All of those things magically appear. The life cycle is also taken care of, which means by the time the test is done, they will be removed from the machine and they will no longer be running on the developer machine. So that's the difference is that it's a convenient way for developers to be able to spin up those dependencies, have this code run this code lives as part of the software that they're working on. So they're never leaving their IDE. The experience for them is they write code, they press a button, it runs, it spins up all the dependencies, run the code, when it's done, removes it. And then they're able to go and iterate on this over and over again. I hope I'm being a little bit, I'm being descriptive enough. Yes. It would have been much easier just to show.
No, that's fantastic. Thank you. Well, and let me ask you this, from a developer's perspective, the advantages seem clear. There's lots of savings there, savings of time, savings of complexity. But if I kind of put the business side, hat on for a second, what are the advantages to a business, and how are they typically measured? Or if I go back to the bunny analogy here, how do we keep the bunny happy? Right? Is it more deployments? Is it less defects? What are the actual metrics to measure in something like this?
So it goes right it's a very core thing to a developer's productivity. It's how productive are your developers? How quickly are they able to iterate on the code? If they're able to get feedback on the code that they're running faster and are able to get it earlier in the development cycle, they're more productive, and frankly, they're happier engineers. This is a core concept for developer productivity and getting more out of probably the biggest expense most organizations have, which are their engineers. On top of it, if you adopt those technologies, one of the things that happen is because you're able to get realistic feedback earlier in the cycle and developers are able to find bugs earlier in the development cycle, the number of failures on a number of things that go wrong during actual deployments and CI actually goes down. But we found, for example, talking to some larger organizations, that for many of them, many CI builds fail because developers, when they were developing, were using one version of a dependency, and by the time it was getting deployed to some kind of a staging environment or somewhere else, it was a different version, and the versions were incompatible. So the more you can bring this feedback, and the more you can bring those things back to the developer, to the IDE, and enable them to get that feedback faster, the less of those failures you're going to find later on in the cycle. And that's very core to the companies that we work with.
Yeah. Let's talk a little bit about the technology again. Give us a sense of the community around test containers. From an open source perspective, obviously it runs the gamut. There's open source, obviously there's a community around it. There's software, there's SaaS, but how did it sort of come to be? Where did the concept come from? How has it sort of grown over time? What's been, are people now thinking about it as just sort of a natural extension of their IDE?
So the technology started about 8 years ago. So it's actually quite a mature technology that's been around for a long time. The good thing, or maybe the challenge for us as a commercial company nowadays, is that up until now, very few people have talked about it. Grown very organically in the community, and it has been adopted by some of the largest technologies out there. So we have Uber, who wrote a blog post about how they're using test containers to reduce flaky tests. DoorDash talked about it. Netflix talked about it. Many of those organizations have been using this technology for a long time, but because there has never been a commercial organization behind this, there hasn't been as much publicity. This has been brewing and kind of getting developed in the open source over the last 8 years. And the pattern that I've described over here of test containers, it came out of the Java ecosystem, but implementations of this test containers technology are now available in Node and Golang and .NET. And when we look at the growth, we look at which languages are growing the fastest. And yes, Java is still growing super fast, but we're seeing huge growth in Node implementation, huge growth in Go and .NET, and those languages repeating the success of the Java implementation. As a company, we're now looking at about when we look at the number of downloads, we're currently tracking about 9.5 million downloads of test containers a month. And it is growing at a rate of about 300% year over year. So it's quite pervasive. Use it. Sometimes I might say something controversial over here, depending on your audience. When we think about what's driving this growth of test containers by developers, and then we go and we talk to some of those organizations. And they tell us, hey, this self-control by the developer and being able to get feedback super early in the development cycle is super appealing. We put two and two together. Sometimes we say developers cheat on their platform by adopting test containers because it allows them to take this technology, just a library, adopt it in their IDE, and get instant feedback without waiting for anybody else to give them the permission to do so, without anybody else, giving them an environment, giving them access to servers or anything else. They're able to do it on. And that's what we believe is driving the growth of this technology so much.
Interesting. So let me ask you sort of one last question. I think we're getting sort of close. And again, this is one of those things that I feel like we would love to dive into this more from the technology. And so we're gonna put some links in the show notes for folks. I think this is a conversation that's, number one, great to kind of learn about what's possible. Because I mean, over and over again, like you said, we're hearing from developers who get frustrated, who get bored, then they get into these loops of their projects take a long time. What is, what do you find is oftentimes the best way for people to get started with it? Obviously, like I mentioned, there's open source versions, there's SaaS versions, but walk us through from that first developer, learning about it, getting used to it, to sort of how it sometimes spreads into, other parts of the team. What are some of the sort of crawl, walk, run patterns that you've seen?
So the way so happy to talk about this. So number one, what we've seen, so we've recently kind of put all of the resources that are available about test containers into a single website that exists, that's called Testcontainers.com, which has a getting started guides, which has all of the concepts explained, which has links to all of the technical documents. We've been investing very heavily as an organization to make sure that the coding experience is as simple as possible, that it's available in multiple languages, that because it's been adopted so much and it's been integrated so much, it's now integrated. It has first-party integrations into Spring, Quarkus, Micronaut, and the Java ecosystem, and the support for other languages is growing as well. So testcontainers.com is the first point where developers usually navigate toward to get all of the information. Then on testcontainers.com, we have a couple of other things. We now have an application that's available for single developers to try, a free application that makes debugging and makes working with test containers even simpler. The application is called Test Containers Desktop. And then for teams that are looking for kind of consistency and ways to test containers on a team and even enterprise level, we have Test Containers Cloud, which is a commercial offering that we do offer to organizations that makes adopting it just simpler and more consistent and solve some of the enterprise challenges around this. But the simplest way to go towards is testcontainers.com. You have access to all of the libraries over there. You can start using it right away. You can download Test Containers Desktop that will give you additional benefits, and then you can go from there.
Fantastic.
That's
awesome.
It's awesome. Aaron, we dug into a lot. We probably just scratched the surface as much as we should have, because again, every development team that I get a chance to talk to, and I know you talk to various developers, it's always, don't just help me go faster, but just make me less frustrated, make things better. I think we uncovered some stuff that hopefully will help a number of those developers with that. Eli, thank you so much for the time today. This has been awesome. I know, it was good to reconnect, but it's also good to see what you're working on these days, and especially when you can find things that seem like they have such an immediate impact. So thank you so much for the time, for educating us and educating the community. Aaron, you want to wrap it up, take us home?
Yeah, absolutely. So Eli, again, thank you so much for your time today. And everyone out there, thank you for listening and taking the time this week. If you have feedback on the show, please send us an email at show@thecloudcast.net. We're available on all the usual socials as well. But if you can, tell a friend. And also, please leave us a review if it is possible for you to leave a review wherever you get your podcasts. And so with that, I'll close us out for this week, and we will talk to everyone next week.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.